Okay, we are going to be learning to solve exponential equations. So we'll be first looking at index laws, which you would have learned in year 8 and year 9. And then we're connecting it to what you should have done in unit 1 and 2 methods. So if you need to go over these index laws and you don't understand where they came from, I would encourage you to look at some of my other videos because I won't be covering that. I will just be applying that understanding. So to start off with, I've got 12 in brackets x to the power of 4, y to the power of -3, to the power of 2, and we're dividing by 4x squared y to the power of -1. So to start off, we are going to get rid of these brackets here and apply the power law. That means this 2 is going to be applying to the x to the power 4, and it's going to be applying to the y to the power of -3. So that means I am timesing the 4 by 2 and timesing the -3 by 2. So 4 times 2 is 8, -3 times 2 is -6. The next part is because we are dividing, that means I'm cancelling, which I'm subtracting. So I'm going 12 over 4, x to the power of 8, take away 2, and -6, take away -1. So that is the quotient rule. So 12 divided by 4 is 3. 8, the x is 8, take 2 is 6. And the y is -6, take away -1 is -5. The next part is I need to apply it in terms of the negative index law because we don't like to keep our powers as negative, so I take the y's to the bottom. And it becomes 3x to the power of 6 over y to the power of 5. Now question B looks a bit different. I'm just going to rewrite it, so I'm going to rewrite it in terms of without a fraction. Now, the next part I'm going to do is I don't like negative powers. I'm going to get rid of that. That means I will make this 1 over x and this 1 over y. Now, if we are going to do addition of fractions, the first thing we need to do is make our denominators the same. So I'm timesing them by each other. So then the top would be y plus x. Okay, so the next part that I need to do is we are dividing, which means I am going to use the rule keep, change, flip. So I keep the first part, I change 2 times, and I flip my fraction. The next part is I'm just going to simplify it by writing it as one fraction. So I've got xy in brackets x to the power of 3 plus y to the power of 3 over x plus y. In a previous video from chapter 4, we went over the sum of cubes identity. That means a cubed plus b cubed is equal to a plus b in brackets a squared minus ab plus b squared. So I'm going to apply that, but instead of a, I'm saying x, instead of b, I'm saying y. Straight away, I can see that we are timesing the top by x plus y and we're dividing the bottom by x plus y, which means I can cancel that part out. And that gives me x squared minus ab plus y squared. Okay, so let's look at the next part. Now we're going to solve, and we're solving so we're not using logs. So that means we're trying to make the base the same for them to be equivalent. So over on my left-hand side, I've got 5. On the right-hand side, I've got this 25. I want to make it equivalent, so I can change it to 5 squared, which is the same as 25. I can use my rules to grab the 2 and take it out here by going 2 times 2x is 4x. Now I can look at, well, my base is the same. I can just look at my powers and construct an equation. So I've got 2x take away 3 is equal to 4x. I take away 2x from both sides, and then I divide by 2, and I get x is equal to -3 over 2. So the next part is with 9 to the power of x plus 2 is equal to 3 to the power of 4x. Again, I'm going to do the same thing, but this time I am rewriting my left-hand side. So we know 9 is the same as 3 to the power of 2. Again, I'll take this 2 onto the outside, so that will be 2 times x and 2 times 2. So now they are the same. I can construct an equation. That will give me 2x plus 4 is equal to 4x. I can take away 2x, and then I can divide by 2, and I get x is equal to 2. The other way we can solve exponential equations is when it looks more like a quadratic. At the moment, I can think about a quadratic as ax squared plus bx plus c. It might not look like that form at the moment, but we can rewrite this first part. So we can write it as 7 to the power of x in brackets squared, take away 8 times 7 to the power of x plus 7 equals 0. So we can think about it as, in our general rule, that x would be the 7 to the power of x. But to make it simpler, we will substitute our u to equal that. So if I rewrite it, it's u squared, take away 8u plus 7 is equal to 0. So now we can look at it as we're looking for two numbers that times together to equal AC, which is 7, and two numbers that add up together to equal -8. Now, straight away in regards to this, we've got a clear two numbers, and they are 1 and 7. Now, we need them both negative to make sure they add up to -8. So based on this, we can go to the next part and we can factorize this now, and we can use null factor law. So now I've got it in this form. This tells me my u must equal 1 and my u must equal 7. But we need to go back to what u is actually worth. So we know u was equal to 7 to the power of x. So I'm saying 7 to the power of x is equal to 1 and 7 to the power of x is equal to 7. That gives me two clear answers. X must equal 0 and x can equal 1. If we do this again for 3 to the power of 2x plus 2 times 3 to the power of x, take away 15. The first thing I'm going to do again is rewrite it in that form. So that means I've just gone 3 to the power of x in brackets squared plus 2 times 3 to the power of x, take away 15 is equal to 0. So the first thing I'm going to do now is again substitute u in as 3 to the power of x and get it into a simpler form. We will use null factor law again, but I can easily see it's going to be 3 and 5, and then 3 will be negative. So -3 plus 5 is equal to 2. Because it's a monic, I can just quickly jump to this step instead of grouping. That gives me u is equal to 3 and u is equal to -5. If I substitute that my u value in, I get 3 is equal to 3 to the power of x, which is x equals 1. And I get -5 is equal to 3 to the power of x. I know any number to the of value of x cannot give me a negative, so it's impossible, which means x must be 1.